Hi. Hi everyone. I'm happy to see y'all on the English workshop about the experience of transition from Monolith to microservices. And just a couple of rules. Our workshop is going to last entirely in English and took at least 1 hour. After the talk, feel free to ask any questions because there will be QA session and our speaker will answer them. So you can start.
All right, thank you. So, hi everyone. Thank you so much for being here today. Uh, my name is Mohammed Rizwan, and I'm a software engineer who's been deep in the trenches of monolith to microservices migration. So, today we are going to talk about something many organizations struggle with. Uh, how to move to microservices without it turning into chaos or becoming a painful experience. So we will explore what we learned, what worked, and most importantly, what to avoid, why it matters. So let's start with why we even bother with this move. So in our case, and likely yours too, uh, releases were slow and risky. Team members would accidentally override each other's code. Scaling was not uniform. One part of the application would spike in usage, but we had to scale the entire monolith application. So that's expensive and inefficient. So on the right, you can see what microservices aim to solve. Uh, Services can be deployed independently, responsibilities are clear, and we can scale what actually needs scaling. So that means that we can scale independently any part of the application horizontally. So when to migrate and when not. So microservices are not a magic bullet. Uh, so you should consider migration only if your teams are constantly blocking each other, or if parts of your system scale differently, or if releases are painful. But and this is important, don't migrate just because microservices looks cool or trendy. So if you don't have the strong ops maturity or the DevOps maturity or the clear domain ownership, things can get worse. So timing and readiness matter more than the hype. Uh, So that is our monolith story. So I want to give you a quick background on our journey. Uh, we didn't throw away the monolith overnight. Our goal was clear. Uh, we create autonomous services with well-defined ownership. Our strategy was evolutionary, and we reviewed our architecture, identified pain points, and gradually moved out domains. So, starting with CI/CD pipelines, it was it was a deliberate, measured process, and that's a same I'll repeat a lot today. So designing the foundation. This is where our transformation really began. Uh, we adapted domain-driven design or the DDD. We mapped out bounded context, logical divisions in our business. Think like user management, product catalog, uh, order handling, notifications, reporting and analytics. So this helped us avoid one big tangle of services. Instead, we had smaller, understandable areas we could build teams and services around. Uh, one of uh, one of the first principles we enforced was API first development. So instead of diving into code, we designed our APIs upfront using OpenAPI. Uh, this helped teams align on expectations uh, before we implemented or before the implementation. So it was like laying down railway tracks before running trains. So it kept us from derailing. Uh, we versioned our APIs carefully and kept design, mock, build, and deploy as separate steps. So domain-driven design. So domain-driven design is not just technical. Uh, it's about aligning with business language and logic. Everyone, like developers, testers, uh, product managers, should use the same terms. So, is it a user or a customer? Is price a number or a value object with currency and discounts? So these distinctions matter, and we make them using domain-driven design building blocks like entities, value objects, and aggregates. So let's expand on these concepts basically. So entities have identity, and they are mutable, like a user with a unique ID. Value objects don't have any ID, like an address or money object. So what are aggregates? So aggregates are the cluster of entities that must be consistent. For example, an order and its order items. So finally, bounded contexts give us mental clarity. Uh, each model lives within a clearly defined domain. Uh, so this structure saved us uh, with so many headaches. Um applying DDD bounded contexts. So bounded contexts were the game changing. Uh, each context had each context had a focused role. Catalog handled products and search. So checkout took care of cards and payments, and identity manager user managed user roles. Uh, so this allowed teams to move faster and independently. No more waiting on someone to finish their part in a shared repository. So it made code ownership and deployment much simpler. So beyond speed, this structure reduced confusion as well. So each context had clear APIs and orders. We used context maps to show dependencies between the services. For example, checkout might rely on catalog, but only through defined interfaces. Uh, this reduced coupling, which is in a key distributed system. So applying domain-driven design aggregated entities. Uh, Inside each context, we define aggregates. Think of think of an aggregate as a unit of consistency. For instance, in order management, we had an order aggregate that included items, shipping information, and billing information. If we updated the order, we updated everything together. So Uh, this avoided weird states like an item being added without corresponding pricing and all the pricing details. Uh, uh, why why go through all this trouble? Because aggregates help us enforce business rules. Uh, they ensure what we emit events like order placed only when the order is actually valid. It helps us keep our system consistent, uh, especially when we start adopting asynchronous event-driven patterns later. So communication between services. Uh, Speaking of patterns, inter inter-service communication is crucial. We used both synchronous and asynchronous models. Uh, so synchronous model was for request reply, like fetching user details, or when whenever we are doing the login, uh, we use a synchronous approach to get the response instantly, so that we can allow our users to log in at the moment. And then we have the asynchronous model as well. So asynchronous was basically for events like users signed up. So we use message queues. Uh, we have the message queues like Rabbit MQ or Azure Service Bus. Uh, so we use them where eventual consistency was acceptable. You need to carefully choose the right model for the job. All right. So CI/CD, done right. Uh, Microservices shine only if your pipelines do too. Uh, I mean, we set up separate CI/CD pipelines for each service. So this meant service A could deploy even if service was broken. So rollbacks were built in, and everything from build to deploy to monitor was automated. So I would say without strong CI/CD pipelines, microservices uh, became a deployment hell, I would say. So here's a here's a slide born from pain. So common mistakes. Making services too small, leading to chatty networks and high complexity, sharing databases, huge red flag. So lack of ownership, nobody knows who maintains what, and skipping automated tests like unit tests or the integration test. So don't do it. Uh, Testing is what saves you when dozens of services go live every day. So what help us avoiding any chaos or disaster? So three things. The first are the future flags. Uh, let us so Future flags let us ship our code without exposing it. Second, a shared glossary. This is this unified our language across teams. And the third is the regular architecture syncs. So short meetings where we made sure everyone was aligned on changes, interfaces, and ownership. Uh, Choosing the right tech stack. So tech stack matters. Uh, but what matters more is where your team is comfortable with it. We choose .NET Core for us. speed and familiarity, since .NET Core is very high much compatible with the microservices architecture. So we have opted for the .NET Core, and since it's open source as well, so that's a good choice for us at that moment. Uh, then we also opted for some of our microservices with Go. So Go handle high performance tasks. And for databases, we opted like uh, Postgres SQL. Uh, it was great for our relational data, and for our documents, we have opted MongoDB, and we kept our communication mostly with the RESTful APIs, with the JWT based authentication and API gateways for control. So observability in microservices. So microservices are like a fleet of airplanes. You need a dashboard and black boxes. Uh, so we use tools like Grafana for monitoring logs, metrics, and traces. Uh, so if I give you an example, one time we saw a slow endpoint. Uh, so we used tracing. We found the bottleneck was in a catalog API. It was a bottleneck in a catalog API query. So fixing that would have taken ages uh without that observability. So invest it in early and try to opt any tool which suits your system, which suits your organization. So there are a lot of monitoring tools like Grafana or Datadog or OpenTelemetry. They all have their uh, pricing structure. Uh, so normally Datadog is normally rich people uses it because since it is a very expensive tool. So and as compared to Datadog, Grafana gives you more or less similar functionalities with a very less price or amount. So security and governance. Uh, Security gets harder with more services. So we used OAuth 2 scopes for access control, MTLS for encrypted service-to-service communication, and key vaults to manage our secrets. So we can use any vaults like we have the Azure key vaults where we can put all our API user secrets, like for example any connection strings or any credentials and username or passwords to access any external resources. So we use Azure key vault for that. And our API gateways handle the rate limiting and the logs. So basically, just to throttle the number of requests that can came through, we have used our API gateway, which is again one of the resource available on the multiple cloud platforms. So we have opted uh, Azure API gateway. So every service had IAM roles limiting database access. So IAM role is the user identity management system, which is available on on almost every cloud platform. So um, you can avoid any vulnerability if if you can at least use these of the few approaches uh, to make your application secure. So organizational challenges and team topologies. So technology is only half the story. Uh, we had to reorganize our teams. We moved from vertical teams to uh, cross functional or the pods are basically, we say it in our software engineering terms, that they are the small teams which work on different products, uh, and devs and your QA and the product managers, so all working on the same service. So we train our product managers to understand the service boundaries. Uh, so this was kind of a, cultural shift, not not just the technical shift or just a technical migration. It was like the organizational or the cultural shift uh, uh, of how we are doing the work. So uh, we use the team topologies model to to structure our organizational stream our organization. So we stream aligned teams which own their own domains, enabling teams, provided tools and patterns. Uh, Platform teams build uh, the shared infrastructure where we can, just deploy all our services. So this thing reduced the dependencies and made our delivery process smoother and faster, since uh, all the teams know their boundaries, and they know what are they are responsible to. This whole thing just reduced the dependencies and uh, made the process smoother and uh, faster. So lessons learned. So let me wrap up with our key takeaways. Uh, that we should always start small. Uh, Prove that microservices add value before going all in. So uh, don't split uh, services too early. Most people they are just overgrown, let's say. So automate testing environment from day one. Uh, and Remember, this shift is as much about people and process as it is about a code. So that's bring us to that. Thank you all for your attention. I hope our experience gave you a few cautionary details. Uh, I'm happy to take any questions. No, also thanks again. Any questions from anyone?
Uh, so we also have 30 more minutes.
Mhm.
Probably you could say something extra while our participants will write some questions.
All right. So, hmm, so I have yeah, uh, so what I was thinking, just to give just to give somewhat knowledge on the domain-driven designs and what patterns we can uh, use along with the domain-driven designs. So since it is critical part for the microservices and how we can you know uh, model or any architecture which can fit well with uh, system or like the microservices. So as I've mentioned earlier, driven design is basically a design which is domain centric. Uh, People normally can use domain driven design um, to to create the good between the users and the developer, anyone who is non-technical and anyone who is technical person. So is a very it's written in the ubiquitous language which can be understandable by both uh, product managers or by your I mean by a developer or any technical person. So let me share the screen as well. So if I say that as I've mentioned, we have the different objects in the domain-driven design with the domain entities, which can be the value objects and which can be why it is important to use a domain. So it is because since we have the separate boundaries or the bounded context, they should know in which context we have to talk. They should know their boundaries, all of the knowledge about that particular domain. So let's system where they have to, it's a system and it's a microservice for the order management. So the project manager should know key entities which we need to use in our API. So let's say in order management, we have one of the entity like each item have uh each item have its ID, each item value, some pricing, uh each item should item type maybe, and how these item types and the value of if there is any kind of address, so we can use any which don't have any ID, and they are classified on the list. So let's say if I have two value of address and where the address is saved. So it will be considered just as a one object because it will only be different when it has a different value. Unlike entities, we have the entity ID, which is a unique ID, and any entity can have the multiple entities with the same values, but with the different IDs. That's the difference between the value object and the entities. And aggregates are like when we cluster multiple values or multiple entities to one, like order management example. We have multiple objects. We can have multiple entities in it, like order, items. We can have maybe the shipping or the billing entity. So each of those entities combinedly make one aggregate. So this give you the very clear picture of how entity management can how these aggregates can create the clustering of your domain. And on the other hand, like I was uh, talks about what type of architectures we can use with the domain-driven design. Normally, uh, it is preferred to use an onion architecture. So we have multiple onion architectures. We have green architecture we can use. Then there are some other where we keep our domain layer separate. Layer which can use our domain, but our domain layer should not directly access any other outer layer. It should be independent, and any of the outer layer may use the domain if they need it. So for example, if I give you an example, we can have the infrastructure layer that can use domain. Our infrastructure layer could contain all the technical or the infrastructure related models and their implementations, like uh, we can have the abstractions for our database CRUD operations. Like for example, if we need to update, delete, or get any record, we can use that. We can use the abstractions from the infrastructure layer, which have nothing to do with the domain logic, because these are the very generic operations which every database needs. So we can keep that out of our business logic and everything in the separate infrastructure layer. And at the same time, if we have any abstractions for our uh, message use, we are using the event-driven system, and we have the separate implementations for different messaging queues. If we need to use them, we can also add them in the infrastructure layer. We can implement any generic implementations uh, for any HTTP calls, or for any RESTful, if you are using any REST API, or let's say if you're using any GraphQL API. So we can create the abstractions for all of those of our uh, uh, infrastructure side of things in the infrastructure layer. And similarly, if it's an API based model, and if it's an API, we could have separate application layers as well, where we may have our separate DTOs. So the DTOs are the data transferable objects, which we normally use like when uh, when we create our API, and our API endpoints need some kind of interactions with the user. So what type of data a user could send? we can use DTOs for it. So we can use the DTO to transfer the customer data into our application. And from there, we can transform those data DTO or the data transfer objects uh, to our domain entities or the value objects, whatever we need. So all of these things could be in the DTOs, and then in the domain, in our domain layer, which is the very key aspect of the domain-driven design. Uh, we could have, as I mentioned, that we could have the domain entity, value objects, or the aggregates, and at the same time, we can put our main business logic in the domain layer as well, since it is something which is related to directly to our domain. So we can create our multiple domain services within the domain logic, which can only use the entities or the value objects or the aggregates we have. So we need to, transform all those objects through through the DTOs we are using. We need to transform it. We Once we transform it, we can have the multiple domain services. Like domain services are like, if I give you an example, it is like, if we let's say if we have any order management system, and we have a business logic that whenever any order comes, we this certain amount of uh, price will be the tax, the certain amount of this is will be the item price, and how we can calculate it, how we can go and look into the repository if we have the certain items in our repository, in our inventory, so we can make it available, otherwise we can't make it available. So all of these kind of business logics should be in the in the main center domain in the main center domain layer. uh, so that is also very important. Then our domain layer contains any infrastructure contracts only, just the interface configuration. For example, uh, if I opt for the repository method, we have we need to see how many inventories, how many items do we have in our inventory, how specific item is in our inventory, or if you want to add any item in the inventory, if you want to, remove any item from the inventory. So we need some repositories in our application to cater all this, and for that we need to use it in our domain layer. So what we can do, because these repositories normally interacts with the database directly, we are supposed to uh, use those infrastructure or data uh, thing in the domain layer, as I've mentioned earlier. So what we do, we create the interfaces, just the abstracts or just the contracts for different functions in our domain. But we need some integration in the infrastructure. So the very big benefit for doing this is, let's say currently we are using PostgreSQL, or and for the messaging we are using the Azure Service Bus, and suddenly we found that no, these or any of these infrastructures that we are using is not feasible for our system. Maybe their prices are too high, or these things are not what our pricing, or not within our budget, or maybe there are some performance issues within those things. So we might have the different options. We see any new technology comes in, like let's say we want to use MySQL, or the SQL Server instead of Monolith, or we choose AWS over Azure. So what at that particular point, that we don't need to change the whole our business logic, we can just plug in the implementation for those in our infrastructure and use it in our domain. or in our domain services. So that is one of the cool, and that is one of the benefit as well for using domain-driven design, that you can choose um, any infrastructure that you want to work with. If you use architectures like the green architecture or the horizontal architecture, so these architectures, these topologies allowed you to use multiple resources or multiple external, I mean, uh, tools that can be integrated well with your business logic without changing any of your code. So I would say that this is one of the very great benefit of using domain-driven design. One of the thing, and as I've mentioned, that it it also gives you the clarity for each domain, for each thing. I mean, uh, if you have the clear picture that uh, these are your specific entities, or these are your specific uh, value objects that you're using. And so any non-technical person, whenever he comes in and he asks uh, what actual properties or what actual values we are using it. So the terms we are using in our domain-driven design models, that are normally the entities or the value objects. They are in the ubiquitous language. So they will easily know. All right, so this is the item price. This is the item expiry date or whatever. So these are one of the benefits other than the microservices that can help to define the clear bounded context for each microservice. So that's where it is. Uh, that's why domain-driven design complements high to the microservices or any event-driven architecture because of its bounded context. So let's say we have four microservices. We have one microservice which is the identity user. Then we have another microservice uh, um, which is the order management, and then we have another microservice which is for analytics or reports. So if each microservice have their own database, have their own domain entities, have their own boundaries, uh, and we need to make change in one of our application, let's say in the user management API, or in the identity API or microservice, it won't affect uh, your other two services. I mean, they can still work. If we made any changes in it, it will still don't have any impact on it, unless, like, for example, if we are once we are doing the login and we send some tokens, or the JWT tokens that are needed for your other APIs, that to access any of the endpoints or anything, because of, like, since we are using the JWT mechanism, OAuth 2 mechanism for our security, and that order management API is alone responsible for all of those things. What we can do, we can just, if we made any changes in the user data, or any user authentication or authorization logic, it still won't affect any of our microservice. So once it is logged in, once it provides the JWT token, we can still be able to access our rest of the other endpoints which are the part of uh, our system, any other microservice. So that is very important to know that you have designed your applications, you have designed your microservice appropriately, that it won't impact any of the other microservice if there is any problem within that particular API. And similarly, as I've talked about the scaling issue earlier. So as I've gave you an example that that we have noticed that when we were in a monolith state, we have a lot of load. Like there's a time, like at 2 p.m. there is a lot of time when people usually do a lot of searches. People do just do search a lot of items. So we have our search microservice basically. So that is just one of the component of the system. But since we were just in a monolith, so what we have seen that we have a lot of load on that particular service, and because of that thing, because of just a spike on that one particular part of the system, the whole applications begins to slow down. We can see a lot of traffic on just one part, but it impacts the whole application. And if we need to scale up, the only option we have at that time that we can just scale up vertically. Vertical scaling means that you scale the whole application, the whole container or the whole server vertically. I mean, if it uses 16 GB of memory, you have increased to 28 GB, let's say, and you have increased the memory as well. So what happens, which will still be unconsumed, but what happens like after a certain time, that load goes down, and still your memory, you're scaling your well, your memory is still over there, which is unused. So that is the kind of problem we were facing. So what we have done that we have analyzed, we have seen that okay, these are the specific areas which we need to figure out. We need to separate these domains. We need to separate these. We need to bounded their context. We need to create a boundaries around that, and we need to create a separate microservices so that if any spikes come to any specific part of our API, only that specific API or the microservice can scale up or scale down independently. Well, so normally we call it the horizontal scaling as well. So if we are using any cloud technologies and our whole infrastructure is working on the cloud infrastructure, so what happens that we can uh, set up the automated scaling as well, where let's say if there is any spike comes in at any particular time, our the cloud has the capability to scale that particular service. It can create the multiple instances of that service instead of increasing the resources. So what it does that it creates the multiple instances of that API, which can handle the load. So that is also one of the uh, great benefit of using microservices architecture. So yeah, that's it. So is there any question from anyone on this or anything? I'd be happy to answer it. Um, Silence means for good. So so since you guys don't have any questions so far, so I can give you one more example. Like previously, I was working for a tracking company. Like it was 4 years back. It's just our case story, one of our case story again, where we have the tracking application, and we have seen that uh like we need we have a lot of like we have 500,000 of vehicles that are sending data to our server. And again, that was the monolith application. And what was the problem over there that we have is that a lot of vehicles, that 500,000 vehicles are sending data to your system at the same time, and there's just one application uh which is reading the application, which is reading the data and the processing the data at the same time, uh and then again save that data as well. for the reporting purposes later. So all of this makes a lot of chaos, and the user experience was also not too good because we can say a lot of delays. The performance was uh, too clunky because the user data we have, what we have to do that we need to go and we need to poll every time, and then once the data is there, we get it, we process it, and we do a lot of things like that. So that is that's also one of the use case where we have seen this problem. And again, we have opted for the domain-driven for the microservices architecture. We have identified the main problems. We have identified the main issues where these things can be handled. But so yeah, what we have done that at that time we have used uh, Kafka. Kafka is also one of the message broker. So how was it working that we have created multiple services? The one service is just the sender service, and another service is a receiver service. So what happens that the sender service is uh is the data which normally that device is using, which is sending the data to a system. That service sends the data to the Kafka queue, to the Kafka, and then we have a receiver service which is listening to the Kafka, which receives a lot of the messages from there. It doesn't need to, do the polling and stuff. It was an event-driven architecture, so it just reads the data whenever it comes in. It keeps listening it and it processes it, and that way, our sender and the receiver service they become the two different parts. So even if the receiver service is down, still the user can send us the data, and whenever our receiver service is up or we have resolved it, if there's any issue, it will start processing all the data which has been sent by the sender asynchronously. So that has enhanced the user experience. Uh, so, so let me just tell somewhat about the Kafka. So Kafka is also one of the message broker which has the very high throughput. It can contain a lot of transactional data at a time. Uh, but it has the low storage memory. I mean, the way any any storage or any databases work where we can store a lot of data, but those databases has a very less throughput. But as compared to that, Kafka has a very high throughput. It can handle uh, the very high throughput, a lot of data at a time. It can, but the only drawback is that it's not a drawback, it's just, I'll call it as a feature that it can just handle the limited amount of data. The reason is that once we process the data, it should be deleted or it should be in the data. It should not be in the message queue. So, so using these topologies or using these uh, approaches might help, not might help, it will help for surely for your system to perform well. You can manage all your teams and your systems in a very well manner. So, so yes, thanks again. Uh, Anything, anyone, any questions? I'll be happy to answer that.
Actually, I saw some questions in the chat. Uh, Probably you didn't see them.
Oh,
If you want, I can say
yeah,
them.
sure. I have seen that. Sorry. Okay. So there are questions. Uh, so how did you become a software engineer? Could you please describe your experience? So yes, uh, since I have a very strong background, family background of the software engineers, mostly of my people are working in this particular field. So I have the interest in the computers and in the technology since I was a kid. So this thing drives me from there. And when I started learning uh, how these softwares are built, how these softwares work, how can we do the programming. And once I started understanding all these, this enhanced my interest again, and that's how my journey begins. Uh, so yeah, when when I finished my intermediate, uh, at the same time, I was very much clear that what I have to do. Uh, since the start, I have opted all the courses which are very much focused to the software engineering. So that's how my journey begins, and then I started my university. I have done my graduation in the computer engineering. Uh, I studied my courses were of software engineering, so that's where I've started, and then I've started my first job. I started my first job in 2013 as a junior programmer, working on the fintech applications, on the core banking applications. And after working a couple of years over there, I have moved to another company, which is a tracking company. I was working with there for quite a while. So yeah, that's how my journey began, and how I became a software engineer. So another from uh, uh, so I have some questions. How do microservices interact with each other? What protocols do you use? So as I've mentioned that microservices, there are basically multiple models which microservices can communicate with each other. One is the synchronous model, and another one is the asynchronous model. So the synchronous model is like the RESTful API calls, the HTTP calls. We can create the HTTP calls to send the request and get the response immediately. And another process is to use any event-driven approach that is more focused on the message brokers or message queues. So what we can do that we can send any notification to a particular queue, and then we have another microservice, which is basically the consumer of that queue, and it reads all the messages which are being sent through another service, and it can process the way which another services can do. So what protocols? There are not as such protocols like for if we are doing the HTTP calls, we can use some secure protocols like MTL. We can use the MTLS or any SSL certificates for the security. Uh, but for event-driven, you should have access to that message, particular message queue or topic. And for MTLS, you should be subscribed as a consumer, or if you're using the message queue, not the notification queue. If you're using a message queue, you should have access to that, and you can pull any message which comes in that message and process it. So that's how normally microservices communicate with each other. So do you another question from Vivek, do you use Kubernetes or another orchestration platform? Uh, so since Kubernetes is one of the very and it is really very handy as well. So we use Kubernetes for managing all our microservices which are running in our cloud. So we use Kubernetes. Another part of your question is what tools are used for monitoring and logging architecture? So I think what I have seen and what we have also implemented that we have implemented is it is one of the most feasible tool for monitoring observability. Can provide all the feature that you need, but not as bad as that at all. But as I said, that it is for the rich people. It is very costly, but using Datadog really gives you of your application. It can give you a lot of the traces. It can give you the metrics, show you the logs. All of the things can be done with there. But I would recommend Grafana as a new trendy tool which can be architecture. So any of these monitoring tools can be compatible with your new architecture that I've mentioned, like Tree or Grafana or Datadog or Microsoft Log. So all of these logging tools can work with this new architecture. Okay, then we have a question from uh were there any cases where moving a service back into the monolith? Uh yes, there are times when we realize that we shouldn't have opted microservices for this particular system. Basically, there was a system where like much need to migrate the whole to migrate it to the microservices from monolith, and what created the very small services, which in after some time creating a lot of pain for us because all of those were like we don't have clear boundaries for those microservices. We have think that we should because what was happening that if any changes break in any other microservice, it was impacting the other microservices inside that system. So which we believe that these services don't have the clear boundaries, they don't have the clear limits. So at that time we have decided to um go back to the monolith architecture, since it is it is useless with three different repositories and three different databases, which are not achieving their purpose. So we moved to the monolith again for that particular service. It's a good question. So yes, I think that's all we have so far. Is there any more questions? So just let me know.
So I guess that we can finish our talk. Thank you for your presentation.
Thank you.
And if nobody have any questions, then we can end our session.
Silence.
So yeah, have a good day, everyone.
All right. Have a good day. Thanks for being here. Thank you.